Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Today's lecture is a continuation of our previous lecture on electrolysis, and the lesson objectives for today's lecture. The first one is where to state the Faraday's laws of electrolysis. Then the second is to calculate the quantity of charge passed during electrolysis using Q is equal to what? Current times time. Then also the mass or volume of substance liberated during electrolysis. So these are the lesson objectives to consider for today's chemistry class. So please, I want us to listen attentively and get the best out of today's lecture. Thank you. Now we'll talk about the quantity of charge. Q passed during electrolysis is given by the equation Q is equal to IT, where I is the current in ampere, T is the time in seconds, Q is the charge in coulombs. So the quantity of charge or the quantity of electricity passed through is equal to current times time. So it's a vital unit or quantity that we have to put into consideration. The quantity of charge, which is equal to current times time. Current is in ampere, time is in seconds. So you have to convert the time to seconds to get the quantity of charge. Q is equal to what? IT. Now we're looking at Faraday's first law of electrolysis. Now the Faraday's first law of electrolysis states that what the mass of a substance produced or removed from at an electrode during electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. We know that the quantity of electricity is in coulomb. So the mass of a substance deposited at the electrodes during electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. What that means is that when the quantity of electricity increases, the mass of the substance deposited also increases. So it can be the mass or it can be the volume. If it's a gas, you have to measure the volume in direct proportion to the quantity of electricity that is passed through. So mathematically, M is directly proportional to what? M is directly proportional to Q. M is the mass directly proportional to quantity of electricity or quantity of charge, which is Q, and the quantity of charge from our previous explanation, current times time. So now, if you remove the variation sign, which is the sign of proportionality, we establish a constant. M is equal to what? ZQ, where Z is what we call the electrochemical equivalent of the substance. So Z is the electrochemical equivalent of the substance. So if we make Z the subject to the formula, Z now will be equal to what? Z now will be equal to M over quantity of charge. So the unit is what? Gram, which is in mass is in gram per watt per coulomb. So where mass M is the mass of the substance repeated in grams, Q is the quantity of electricity in what? In coulomb. So Z is equal to mass over quantity of electricity. So it's as simple as what? So based on Faraday's first law of electrolysis, that the mass of substance that is deposited at the electrodes during electrolysis is directly proportional to the quantity of electricity. So as the mass of the substance deposited or the volume of the substance deposited increases, the quantity of electric current that passes through also increases. So graphically, we can represent what Faraday's first law of electrolysis graphically. So I just want to show the graphical representation of Faraday's first law of electrolysis. So if you plot a graph of M, which is mass against quantity of electricity, you have a straight line graph of this nature, that M is directly proportional to the quantity of electricity that passes through. M is directly proportional. If you plot a graph of mass against the current, you have what? A straight line graph. You plot a graph of mass against the time, you have what? A straight line graph. So the mass mathematically directly proportional to Q. Then you have your electrochemical equivalent, which is a constant. Since Q is equal to IT, M can represent mass is equal to electrochemical equivalent times the current times the time also. Then the Z, which is the electrochemical equivalent, which is the constant, will be equal to mass over what? Quantity of electricity that passed through, which is equal to mass over what? The current times the time. So it's as simple as what? ABC. So this is just a graphical representation of Faraday's first law of electrolysis. So Faraday's second law of electrolysis, we want to look at the Faraday's second law of electrolysis. Now the Faraday's second law of electrolysis states that the number of Faradays required to discharge 1 mole of an ion at an electrode equals the number of charges on the ion. that is the number of Faradays required to discharge 1 mole of an ion at an electrode equals the number of charges on the ion. So the Faraday is the charge carried by 1 mole of electron. Faraday is the charge carried by 1 mole of electron. Now mathematically, one electron will give you a charge of 1.60 times 10 raised to the power what? Minus 19 coulomb. If one electron give you a charge of 1.60 times 10 raised to the power minus 19 coulomb, that means 1 mole of electron, which is equal to 6.02 times 10 raised to the power 23, will give you what coulomb? So if you calculate the coulomb, you cross multiply, you will get, mathematically, you get what? 96,500 coulomb. Now this 96,500 coulomb is equal to what? 1 Faraday, because 1 Faraday is the charge carried by 1 mole of electron. So the charge carried by 1 mole of electron is equal to 96,500 coulomb. That means Faraday will be equal to what? The Avogadro's constant, which is 6.02 times 10 raised to the power 23. We use L to represent the Avogadro's constant, times the charge carried by 1 electron, times E. So the Faraday's is equal to what? L E. So which is the Avogadro's constant times the charge carried by 1 electron. So therefore 1 Faraday is equal to 96,500 coulomb, which is the charge carried by 1 mole of electron. So this is the relationship between the Faraday's constant, the Avogadro's constant, and the charge carried by 1 electron. So it's as simple as ABC. I want us to take note of this mathematical representation, because by the time we go into calculations, we're going to apply these formulas, and we're going to use the relationship to calculate the Faraday's constant, to calculate the Avogadro's constant, to calculate the charge carried by the 1 mole of electron. So we use it in calculation. So it's as simple as ABC. So just to summarize, that the Faraday's second law of electrolysis states that what? The number of Faradays required to discharge 1 mole of an ion at an electrode equals the number of charges on the ion. So applying Faraday's second law of electrolysis in the electrolysis of an electrolyte or an aqueous solution or molten solution. Let's take, for example, during the electrolysis of silver nitrate solution, silver is deposited at the cathode. So 1 mole of electron is required to deposit 1 mole of silver. So 1 mole of electron, which is needed, 1 mole of electron, is equal to what? 1 Faraday is equal to 96,500 coulomb, required to deposit what? 1 mole of what? 1 mole of silver, which is equal to the relative atomic mass of silver, which is 108 grams of silver. So with this relationship, we can easily solve calculations that has to do with what? That has to do with the mass of the substance deposited, or the number of moles of substance deposited. So 1 Faraday of electricity requires what? 96,500 coulomb to deposit 1 mole of silver, or 108 grams of silver. So still on Faraday's second law of electrolysis, this is another example. During the electrolysis of copper 2 surface solution, copper is deposited at the cathode. So you discover that 2 moles of electron is required to deposit 1 mole of copper. So that means 2 moles of electron will be equal to what? 2 Faradays, which is equal to what? 2 times 96,500 watt coulomb. That means 2 Faradays will deposit 1 mole of copper, which is equal to what? 63.5 grams of copper, which is the relative atomic mass of copper. So 2 Faradays, which is 2 times 96,500 coulomb, is required to deposit 63.5 grams of what? Of copper, which is equivalent to 1 mole of copper. So with this, we can calculate the mass of copper deposited, or the number of mole of copper deposited at the electrode. So it's as simple as A, B, C. So still on Faraday's second law of electrolysis. So during the electrolysis of an aqueous solution of sulfuric acid or aqueous sodium sulfate, oxygen is produced at the anode. So we want to look at the reaction that takes place at the anode. So from the equation, you discover that what 4 moles of electron is required to deposit 1 mole of oxygen gas at the anode. 4 moles of electron, that means 4 moles of electrons will be equal to 4 Faradays, which is equal to 4 times what? 96,500 coulomb. That means 4 Faraday is required to deposit 1 mole of oxygen, which is equal to what? 24 dN cube of oxygen, and which is equal to what? 32 gram of oxygen, which is the molar mass of oxygen. So with this, we can calculate the volume of oxygen that is deposited at the anode, or we can calculate the mass of oxygen deposited at the anode. We can calculate the number of mole of oxygen deposited at the anode. So 4 Faradays, which is 4 moles of electron, is required to deposit what? 1 mole of oxygen from the equation. So the equation is very, very important. You can see that the equation shows that 4 moles of electrons are released when 1 mole of oxygen gas is formed from 4 moles of hydroxide ion. So it requires 4 Faradays, which is 4 times 96,500 coulomb, to produce 1 mole of oxygen, which is equal to what? 24 dN cube of oxygen at what? At RTP. Oxygen at what? At room temperature pressure at RTP, which is room temperature and pressure. So it's as simple as what? ABC. So with this, we can solve as many calculations as possible. So you have to understand this concept very, very well. And you should be able to write the equation that takes place at the anode and at the cathode to confidently what? Solve any problems on this. I'm Mr. Joe, your chemistry teacher. So as you watch or you go through the video, if you encounter any difficulty, feel free to reach out to me. I'm always there for you. Please don't forget to subscribe to my YouTube channel, share, like, comment, and feel free to reach out to me. I'm always there for you. Mr. Joe, your chemistry teacher. Thank you very much.